All right, we're going to go ahead and get started with section 1.6, which is going to be broken up into 3 different parts. We're going to be talking about the different transformations that are possible when it comes to graphing. So today we're going to talk about just what are the different transformations that are out there. And then more specifically, we are going to focus in on the vertical and horizontal translations with graphing. So first of all, the different transformations that we are going to be looking at is, we're going to be transformations. We got translation, a reflection, and a dilation. What all of these transformations are doing is they are changing the shape and or location of the parent function. And when I say a parent function, remember those are our functions of our quadratic, y equals x squared. It's our absolute value function, y equals the absolute value of x, and so on. So first of all, we have a translation, which we'll focus on today, which is sliding a graph up, down, left, or right. Then we have a reflection, which we'll focus in on day 2, which is going to flip the graph over a given line. And then the third day, we're going to talk about dilations, which this is going to change the size of the graph by a vertical or a horizontal stretch or shrink on those two. So as we get going here, we're going to talk about what a translation is. So a translation in the plane is a transformation that maps the point of x, y onto the point of x plus h and y plus k. What this does here is it's moving your graph to the left or the right, or it's moving it up or down. And starting out with this problem here, h is going to be taking that graph and moving it left or right. When you think about moving a graph left or right, you're affecting the value of x. And so if I was to move this graph 3 points to the right, I would have to take every x value and add 3 to it to be able to move everything to the right. With y, if I wanted to move the graph down 5 units, I would have to take all of the y values. I would have to subtract 5 units, and that would bring our graph completely down. How I'm going to illustrate this a little bit is I'm going to go ahead and look at some graphs on the graphing calculator. So here I have the parent function of the absolute value function all graphed out for us. And then I have 2 different equations here. So there's my parent function. I'm going to go ahead and go into y equals, and I'm going to graph out the second equation, which is the absolute value of x, and then outside there I'm going to add 3. So once I graph this, what you'll notice here is that I have the exact same V shape, but it's being moved up. And the vertex of our graph, which started at 0, 0, is now moved up to 3, 0. So by adding 3 here, what I'm doing is I'm moving my graph up 3 units. If I go back to my graph and down here in y3, if I enter the third equation, which is the absolute value of x, and then I'm going to subtract 2. Once I graph it, we should be able to see that my third graph now, the vertex, again, what started at 0, 0 with the parent function, now has been moved down 2 units to 0, 2. What we like to think about this here is we like to think of this being outside change. Okay, you are doing something that is outside of what's inside your absolute value. So the plus 3 is outside the absolute value, the minus 2 is outside the absolute value. So I'm going to go into the graph translation theorem, which says that if you have a function and then you're going to subtract some positive real number, what's happening here is that you are going to be moving your function down c units, and it's because you're subtracting c. If you were taking your function and you're going to add some number to it, what's going to happen here is then your function is going to be moving up c units. So if I go back to the previous problem here, absolute value of x plus 3, this adding 3 here is what's moving that graph up 3 units. And here when I'm subtracting 2, what's happening now is it's moving our graph down 2 units. So you have what we call outside change for those 2 problems. So now let's look and see what happens if you do some what we call inside change. If I were to put something inside with the values of x. Now since with the last one here we moved up and down, what's a lot of people like to think here that happens is, okay, I'm going to move it to the right 4, and then I'm going to try and get rid of these graphs here. I'm going to move it to the right 4, and I'm going to move it down 6. So let's see what happens here. I'm going to take the absolute, I'm going to get rid of my third one. I just not have it graphed. So for y2, we're going to take the absolute value of x plus 4, and I'm going to go ahead and delete that plus 3. And now I'm going to graph this, and let's see what's happening. So there's my parent function. Now notice where my new graph is. What most people think is going to happen is that's going to move to the right 4 units, but actually it's moving to the left 4 units. If I go and I want to do the third one, so we're going to take the absolute value of x, and we're going to subtract 6. And I'm going to go ahead and delete this minus 2 off of here. And now once I look at this graph, notice that it's moving to the right 6 units. What we have going on here is we have what we call inside change. And inside change is opposite of what's being done here. So x plus 4, even though we think it might move to the right 4 units, it's actually moving to the left 4 units. Here, if I take x minus 6, I'm actually moving to the right 6 units. And so the graph translation theorem here, now again we're working with the inside change. If inside your function here you have x minus some positive real number, what's going to end up happening here is because it's subtracting, so x minus, your graph is actually going to move to the right c units. If you have inside your function x plus c, your graph is going to be moving to the left c units. So as we start looking at a couple examples here, hopefully this will start to be ingrained in your mind, and you'll see why this is all taking place. So I'm going to go back to the whole mapping idea that we talked about, and where I have the mapping of x, y, and it gets mapped onto x plus h and y plus k. So again, h is telling you if you're going to the right or the left. If h is positive, you're moving to the right. If h is negative, you'd be moving to the left. If k is positive, we'd be moving our graph up. If k was negative, we'd be moving it down. Well, the graph translation theorem says that if you're given a function, how to make your equation do what you want it to do, so if you wanted your graph to move down, if you wanted it to move to the left, what we do here is we replace the value of y with y minus k. So based off of where you want to go, if you want to move to the right 5 units, we're going to remove the y and replace it with y minus 5, even though we want to move to the right. If we want to move our graph, say, down 4 units, I'm going to replace x with x minus h, which would be x minus a negative 4, and I would end up with x plus 4. So let's take a look at an example here. Here I have a function t. I'm going to do it a translation, and I'm going to move my graph 4 units to the right, and I'm going to move it down 2 units. So this is telling me that my value of h is positive 4, and my value of k is equal to negative 2. Now I'm going to be working with the the quadratic function, parent function, of f of x is equal to x squared. Now remember that this is the same thing as y is equal to x squared. What we're going to do here is we are going to use this theorem, and we're going to take this value of y, and we're going to replace it with y minus k. Now k is equal to negative 2, so I'm going to be replacing that y with y minus a negative 2, which is the same thing as y plus 2. I'm going to take this value of x, and we're going to be replacing that with x minus h. So in our case here, we're going to go with x minus 4. Once I take these values and I replace them, now I end up with y plus 2 is equal to, now I have to make sure I put this in parentheses, because it's x squared, x minus 4, that quantity squared. Now let's say I wanted to graph this out to actually see, did we move to the right 4 units? Did we move down 2 units? If I were to put it into my graphing calculator, I'd need to solve my equation for y. So I'd have to bring the 2 over to the other side, and I would get y is equal to the absolute value of x minus 4 squared minus 2. So my new function here of f of x is the quantity of x minus 4 squared minus 2. To go ahead and kind of look at our graph just to kind of see what it's looking like. Get rid of my 3 graphs here. So y1, I'm just going to go ahead and graph the parent function just so you remember what that looks like. There's our parabola. And now we're going to go ahead and graph the second one. And in parentheses, I have x minus 4. Take that value squared. And then I'm going to subtract 2. And what I'm hoping is happening here is that I'm going to move my graph to the right 4 units and down 2 units, which if I look at my vertex here, which was at 0, 0, it's moved over 4 and it's moved down 2 units. So we've been successful in coming up with our new function after the translation has taken place. Just a few more examples to kind of look at here. I have some different functions. So I've got the natural log function. I've got, again, the quadratic function. And then I have e to the power of x, which is an exponential function. Just to kind of get you an idea here, let's say we want to do a few different translations. Here I want to take my natural log of x and move it 5 units to the left and 6 units down. So that means that my value of h is going to be negative 5, and my value of k is going to equal negative 6. With this problem, think of it as y equals the natural log of x. We're going to replace y with y minus k. So that's going to be y plus 6 is equal to the natural log. And I'm going to replace x with x minus h. And so that would be x plus 5. By subtracting 6 from both sides, now I get my function of f of x is equal to the natural log of x plus 5 minus 6. Now what's going to happen is many of you might be able to go right from your parent function to the translated function without doing the y part, and that's perfectly fine if you can see the pattern that's happening here. On the next one real quick, here's our quadratic. 6 units to the right, so h is going to be positive 6. 2 units down, k equals negative 2. So we have y is equal to x squared. Replace y with y minus k. So y minus 2 is equal to, and we're going to replace x with x minus h. So x minus 6. Solve it for y. We end up with the function of g of x is equal to the quantity of x minus 6 squared plus 2. And the last and final one that we have here is function w, which is e to the power of x. 4 units up. Now be careful, this is our k value. So k is going to be a positive 4. 3 units to the right, that tells us that h is going to be positive 3. And now we're going to replace our values. So y is equal to e to the power of x. So now I have y minus k, so y minus 4 is equal to e to the power of x minus h. And so my exponent is going to be x minus 3. Bring the 4 over, and we end up with the function of w of x is equal to e to the power of x minus 3 plus 4. And there we are. If any of these did not make sense, I suggest that you go back, watch the video again, so that you're able to kind of see what's happening with that graph translation theorem. What I'd like you to try and do for class tomorrow is reverse this process. So I have 2 functions here, t of x and p of x. And what I'd like you to try and do is, can you distinguish what the parent function is of these two functions and what's happening to that parent function? Okay, so we're working backwards. If I were to be starting with this function right here, hopefully that natural log that I see, I can see, okay, it's going to be the natural log of x, and then I can see with the 5 and the -6 of what's happening, and I'm going 5 units to the left and 6 units down. So I want to see, can you try and work backwards? So for class tomorrow, given the two translated functions, can you try and figure out what the translation description is, and then what parent function is being used? Hopefully I was almost able to keep it under 15 minutes. So if you have questions, make sure you write them down and let me know what I can help you with.